Before we jump into chapter 8, we're going to spend a couple days reviewing how to simplify square roots. This is a skill that you have already seen in algebra. It's just something that we'll do a whole lot in chapter 8. So it's worthwhile to take a couple days to make sure that we actually remember what we're doing. This first page is just some vocab that you might need to remember. So a radical is an expression that has a square root in it. It could also be a cube root, a fourth root, a fifth root, but in the case of geometry, we are only going to see square roots. So the square root symbol is actually called a radical. The number we put underneath the square root symbol is the radicand. And then every single root has an index. If you don't see an index there, we assume it's a square root, so it'll have an index of 2. The index is just how many times I multiply a number by itself to get the radicand. So a square root would be, what do I multiply by itself 2 times in order to get, in this case, it's 19. On the right, you see a cube root. So that would be, what do I multiply by itself 3 times in order to get 15? If you had a 7th root, it would be, what number do I multiply by itself 7 times to get the number under the radical? All right, so we need to simplify a radical if we see one of 3 things going on. The first one is if the radicand, if the thing underneath the square root, has a perfect square factor. So perfect squares are just numbers made by squaring another number. So 2 times 2 is 4. 4 is a perfect square. 3 times 3 is 9. 9 is a perfect square. 4 times 4 is 16. So 16 is a perfect square. Examples of some radicals that would need to be simplified. The square root of 8, well, 4 and 2 are both factors of 8. So since 4 is a perfect square, we could simplify that. Same thing with the square root of 80. 80 can be broken down into 16 times 5, and 16 is a perfect square, so that would have to be simplified. So that's our first case if you have a square root under the radical. Our second case is if your radicand is a fraction, like the square root of 2/3. And the third one is if you have a radical in the denominator of your fraction, like 8 over the square root of 3. We're going to save the fraction ones for our second lesson on simplifying radicals. So today we're just focusing on pulling out perfect squares. So the big idea we're going to need for today is if you have 2 things multiplied under a radical, we can break it up. So the square root of a times b is the same thing as the square root of a times the square root of b. In this example, the square root of 4 times 5 would be the same thing as the square root of 4 times the square root of 5. The square root of 4 is 2. Square root of 5 can't simplify. So the square root of 4 times 5 would actually simplify to 2 times the square root of 5. And there are other ways you could say that. Sometimes I say 2 root 5 or 2 square root 5 or 2 radical 5. All those things just mean 2 times the square root of 5. All right, let's do a couple examples. Whenever I see a square root and I'm trying to simplify it, I always kind of go through a list of perfect squares. So I'll typically write them like off on the side of my paper, and I'll try and find the biggest perfect square that might possibly go in the square root. So first thing I want to find is the square root of 18. Well, 18 falls between 16 and 25. So I'm just going to go backwards through my list of perfect squares and find the biggest thing that would go into my radicand. So is 16 a factor of 18? No. Is 9 a factor of 18? Yes. Let's use that one. So the square root of 18 can be broken into the square root of 9 times 2, which is the square root of 9 times the square root of 2. Square root of 9 is 3. The square root of 2 doesn't simplify, so my solution is 3 times the square root of 2. My next example is the square root of 50. So again, I look at my perfect squares list and I try and find the biggest possible number that is a factor of 50. Well, 50 would fall between 49 and 64. 49 is not a factor of 50. 36 is not a factor of 50. 25 is a factor of 50. So let's take the square root of 50 and make it the square root of 25 times 2. That's the same thing as the square root of 25 times the square root of 2. Square root of 25 is 5. The square root of 2 doesn't simplify, so that one would be 5 times the square root of 2. If we've got a number out front of our radical, we treat these problems the exact same way. It's just our final answer is going to be multiplied by 3 in the first example and multiplied by 4 in the second example. So first thing I want to do is I want to find the biggest possible perfect square that goes into 180. I know 9 will definitely go into it, but we could probably find a bigger one. I think 36 is going to work. So I'll test that out in my calculator just by doing 180 divided by 36, and I get 5. So since that's a nice even number, that'll work for us. So we're going to take 3 square roots of 180 and break it into 3 times the square root of 36 times 5. Be sure you keep carrying down the 3 out front. We'll break that into 3 square roots of 36 times the square root of 5. The square root of 36 is 6. Square root of 5 doesn't simplify. And then 3 times 6 is 18. So our solution there is 18 square roots of 5. When you get to the end of these problems, you can always double check by putting what you started with and what you ended with into your calculator and see if you get the same decimal answer. So 18 square roots of 5 in a calculator, I get 40.249. 3 times the square root of 180. I get 40.249, so I know I did that problem right. All right, another example, I'm looking at 4 square roots of 726. So I want to find a really big perfect square that goes into 726, save myself some time. I'm just going to test a couple of the big ones on my list. 726 divided by 121 is 6, so let's start with that. So we'll take this and make it 4 square roots of 121 times 6. Square root of 121 is 11. So that solution would be 44 times the square root of 6. All right, just a couple more examples. What do we do if we have a variable in there? Well, we're going to find our perfect squares still. Remember, a perfect square is just made by multiplying a number by itself. So x times x would be x squared. X squared is a perfect square. Y times y y squared, so y squared would be a perfect square. So anything raised to the second power is going to be a perfect square. So in our first example, we've got the square root of 4x to the 5th. Think about what x to the 5th power means. That means x multiplied by itself 5 times. So this is actually the square root of 4 times x times x times x times x times x. That doesn't help us out too much, but I just wanted to visualize that and show you what x to the 5th power means. So again, we are looking for perfect squares. We're looking for x to the 2nd power. So I'm actually going to rewrite this as the square root of 4 times x squared times x squared times x. So that's still x multiplied by itself 5 times. And then we're going to do just like we did with the other problem, separate this out to be the square root of 4 times the square root of x squared times the square root of x squared times the square root of x. Well, the square root of 4 is going to be 2. The square root of x squared is going to be x. I've got 2 of those. And then the square root of x doesn't simplify. So our solution is 2 times x times the square root of x. Let's clean that up a little bit. 2x squared times the square root of x is our simplified version. All right, on the right, I'm looking at the square root of 16x cubed y to the 4th. Again, I'm going to break this up into variables raised to the 2nd power. So let's rewrite this as the square root of 16 times x squared times x. So that's my x to the 3rd power times y squared times y squared. And then when we have things multiplied under a square root, we can break it up to the square root of 16 times the square root of x squared times the square root of x times the square root of y squared times the square root of y squared. The square root of 16 is 4. Square root of x squared is x. Can't do anything with the square root of x. Then I've got a y and a y. We're going to clean that up a little bit. I always want to put my square roots at the end and anything that I pulled out at the beginning. So this would be 4xy squared times the square root of x. All right, let's do one more example in this video. So the last problem I'm doing is the square root of 5x to the 17th power. So just like before, we're going to separate out our units of x squared. If you wanted to, you could write out 5 times x squared and keep going up until you got your 17 x's. I'm going to take a shortcut though. Instead of writing out 8 different sets of x squared, I'm going to say, well, I'll use 16 of those x's to be pairs because that's an even number. And then I'll have 1 x left over in the square root. So I've got the square root of 5 times the square root of x to the 16th power times the square root of x. Square root of 5 we can't change. The square root of x to the 16th. So think about what would I multiply by itself to get x to the 16th power? Or you could think about if I were writing that out in x squared times x squared times x squared, how many of those pairs would I need to get up to 16? That would be 8. So I'm going to have an x to the 8th power outside of the square root, and then I'll have 1x left over inside. Let's clean that up a little bit. It'll be x to the 8th power times the square root of 5x.